Physics Part 35. These checks will not enable you to say which of the instruments are calibrated correctly, but they will show you if there is a discrepancy. Reaction time of experimenter. When timings are carried out manually, it must be accepted that there will be a delay between experimenter observing the event and starting the timing device. This delay, called the reaction time, may be as much as a few tenths of a second. To reduce the effect, you should arrange that the intervals you are timing are much greater than the reaction time. For example, you should time sufficient swings of a pendulum for the total time to be the order of at least 10 seconds, so that the reaction time of few tenths of a second is less important. Ammeter has a zero error about minus 0.1 ampere. Random uncertainty error. The random uncertainty results in reading being scattered around the accepted value. Random uncertainty may be reduced by repeating a reading and averaging, by plotting a graph and drawing a best fit line. Examples of random errors are reading a scale, particularly if this involves the experimenter's judgment about interpolation between scale readings. Number 2 is timing oscillations without use of reference market, so that timings may not always be made to the same point of swing. Taking readings of a quantity that varies was time, involving the difficulty of reading both timer scale and other meters simultaneously. Reading from the different angles and reading of a scale of different angles to introduce variable parallax. Taking readings of quantity that varies with the time, involving difficulty of reading both the time scale and other meters simultaneously. Reading a scale from different angles, so introducing a variable parallax error. In contrast, a scale reading is always made from the same non-normal edge, and this will introduce a system of error. There is an example. The current in a resistor to be measured using an analog ammeter. State one source A, systematic uncertainty, B, random uncertainty. In both cases, suggest how the uncertainty may be reduced. A systematic uncertainty could be a zero error on the meter or wrongly calibrated scale. This can be reduced by checking for a zero reading before starting the experiment, or using two ammeters in series to check that the readings agree. Random uncertainty could be a parallax error caused by taking reading from different angles. This can be reduced by the use of the mirror behind the scale and viewing normal or envying normally. Now it's your turn.